All right, this video is going to be broken up into two parts to cover the entire test review since it does have some lengthy parts to it. So this first part will cover numbers 1 through 20, and then part 2 will cover the rest. Right. For number 1, you're filling in a blank with a key vocabulary word. It's asking you the blank of linear equations consists of 2 or more equations in the same variable, and that would be a system because you have more than one. Number 2, a blank of a system of linear equations in two variables is an ordered pair that satisfies both equations in the system. And because it's an ordered pair, that would be the solution to your system. Remember, all solutions are written as ordered pairs. For number 3, is 3, -6 a solution to the system of equations given? The best way to do this, remember, is to check it out. So we need to plug in the 3 and the -6 where the x and the y stand. So in the first equation, that's 4 times 3 minus -6 equals 18. I'm going to multiply first. 4 times 3 is 12. 2 negatives make a positive. 12 plus 6 is 18. 18 equals 18. It works in the first one. You cannot automatically assume that it's going to work in the second one without testing it out. Right, so when we go to test it out in the second one, same two numbers go in the x and the y spot. So this is 3 minus 2 times -6 equals -15. -2 times -6 produces a positive 12. So 3 plus 12 equals -15. When we're finished, positive 15 equals -15 is not a true statement. So because one of these equations it did not work in, the entire ordered pair will not work. So it's definitely a no. For 4, 5, and 6, these are true-false statements, and instead of using a graph of them, if you use your knowledge of the signs, then you'll be able to answer these questions without showing any work. For number 4, any point that lies on the line x plus y equals 4 is a solution of the inequality x plus y is greater than 4. Well, in order to be a solution of a line, you have to have the equal to component. If you look at your symbol, it's just greater than. There is no equal to bar, so this is a false statement. Had it said equal to, then we could have said true. For number 5, the graph of y is less than 3x plus 5 is the half plane below the line. In other words, they're asking you about the shaded area. Again, you do not need to graph this. Look at the symbol less than, right, and think about your hand and the trick I taught you in class. If it's less than, then you're going to shade below your hand, which is below the line. So this is a true statement. For number 6, the graph of the inequality x minus y is greater or equal to 7 contains the points on its boundary line. Because it says contains the points, that means they are on the line. Right? And again, we don't need to graph this to do this. If you look at the greater than or equal to sign, because it has that equal to piece, it contains the points. So this is a true statement. Right? So just knowing your details about your signs and your graphs, you can answer a lot of these questions without doing heavy-duty work. For number 7 and 8, you are asked to graph to solve. So this is using the graphing method, right? And the first thing we always must do is make sure our equations are in intercept form. The first one is ready to go, so we're going to take the second one and get the y by itself. First thing we need to do is add x to both sides. Now you have -4y equals x minus 4. Divide everything by -4. And you end up with y equals -1/4 x plus 1. Now we're ready to graph both lines. And remember, these lines should intersect at an ordered pair if we've done the method correctly. So for the first line, you're going to start at -2, that's the y-intercept, and the slope is +1/2, so that's up 1, right 2, up 1, right 2, and you keep doing that. Yours will be more accurate because you are able to use a straight edge. With me doing this on the smartboard, it does not come out as perfectly as I would like it to, but here's the best that it's going to be. For the second equation, we want to start at +1 on the y-axis, and our slope is -1/4, so that means down 1 and right 4, down 1 and right 4. And you can see, because we've done this right, that our graph is going to cross each other at one point, which is a good thing. Okay, so now the answer to this is not your picture. In the picture is the ordered pair where those two lines have crossed, and that ordered pair is your answer. So the answer to this system would be 4, 0, because you go right 4 and up nothing. For number 8, same thing. We need to get y-intercept form first before we can graph anything. So for the first equation, I'm going to subtract x from both sides. So now I've got -y equals -x plus 2. I want to divide by -1 to everybody, and that gives me y equals x minus 2. Right? Go to the second equation, and what I want to do first is add the x over. So now I've got 2y equals x plus 2. Divide everybody by 2. And my equation is y equals 1/2 x plus 1. Right, now we're ready to graph. Right, so for the first equation, I want to start at -2 on the y-axis, and my slope is +1, which means rise 1 and run 1. So up 1, right 1, up 1, right 1, and keep going. Okay, so do make your line with a straight edge as best you can. Again, we'll see how accurate mine comes out being without a straight edge. Right, and then the second equation, you're going to start at +1, and your slope is 1/2. So that's up 1, right 2, up 1, right 2, and so forth. Right, and looking at this, looks like mine might cross at the right spot based on the line. Right, you're going to see that they cross at the point of intersection, which would be right here. Right, and that would be the ordered pair of +6, +4. Okay. And remember, with the graphing method, I've shown you in class how you can type them into your graphing calculator and find the point of intersection accurately with that. So you can always check behind yourself and see if what you've done on your test is the right answer or not. Okay. For number 9, it is asking you to write a system of equations to represent the word problem. You are not solving it, you are simply just writing it. We've practiced this several times in class. So again, you will have to demonstrate that you are competent enough at actually writing the equations. Remember, the very first thing you need to do is identify what's going to be your x and what's going to be your y. Right? So you and a friend are going to Taco Bell for lunch. You order 3 soft tacos and 3 burritos. Your bill is $11.25. Your friend's bill is $10 for 4 soft tacos and 2 burritos. How much do soft tacos cost and how much do burritos cost? Again, we're not trying to find the actual answer. We just want to set up the system that will get us that answer. So our 2 different variables are going to be x for soft tacos and y for burritos. Right? The first equation is going to be your order. So you ordered 3 soft tacos, that's 3x, and 3 burritos, so that's 3y, and your total was $11.25. The second equation is going to be your friend's bill, right? And they ordered 4 soft tacos and 2 burritos, and their bill was $10. Right? So that's all you need to do for this problem, right? In future problems, you may be asked to actually write the system and solve it, but in this case, we are only practicing the writing component of it. Right, for 10, 11, and some more on the back, you're going to see that they are multiple choice questions. I will not work out every little choice through every single problem, but I will talk you through how to get the right answer the way I did, and we'll go from there. For number 10, which ordered pair is not a solution of x plus 5y is less than 15? So with this, you need to plug in each ordered pair to see who does not make a true statement. Right? So once you plug in your x and your y, it has to make something that's going to be true, or you can't pick it. All right, so if we go through, the correct answer is C. C is the one that does not work. So I'm going to show you why it does not work. Everything else will work. So if you come up with something different, then you'll need to ask me about that in class. All right, if we plug in our x as 1 and our y as 3, and we check it out, 5 times 3 is 15, so this is 1 plus 15 is less than 15. 1 plus 15 is 16. Is 16 less than 15 a true statement? No, it's not. So because we are looking for the one that is not true, we found it with letter C. All the other ones, A, B, and D, when you plug them in, will come out with a true statement in relationship to 15. For number 11, you're looking at which inequality makes the picture happen on the screen, right? Well, you can tell a couple of things just by looking at the graph. First of all, none of the equations are in intercept form, so we've got to work with that, right? But if you look at the graph, it is a solid line and it's shaded underneath the line, which is going to automatically tell you that your symbol has to be a less than or equal to sign, which means I can rule out letter B and I can rule out letter D because they aren't going in that direction. Right? So then I need to take a look at letters A and C. Right? Well, if I take a look at letter A and I put it in slope-intercept form and I subtract my x over, I get y is less than or equal to negative x minus 1. And then if I check it out on my graph, negative 1 is here, that's the y-intercept, that works. And then slope is negative 1, down 1, right 1, that's how I get to my next point. So A is the answer just by knowing a couple pieces about what you're looking at. If you go to the back side of this first sheet, you're looking at another graph, and this is a system of inequalities, and you have to figure out which system makes that graph happen, right? So again, it comes down to knowing your signs. You don't have to do a whole lot of heavy-duty math with this one. Take the dashed line first, this one that I'm pointing to, right? It goes through the origin, so that means the B is 0, And if you go up 2 and right 1, you'll get another dot on that line. So that means the M is 2. And if you notice that the line is dashed and it's shaded below the line, then that's going to give you y is less than 2x. Right? And if you look at your answer choices, there's only 2 possible answer choices that have y is less than 2x in them. So you can throw out letter C and you can throw out letter D because they're definitely not going to be it. So then if you look at the second inequality in both of these systems, A and B, one of them has a less than sign for the next line and the other one has a greater than sign for the next line. If you look at the next line, this one right here, and you notice the shading is on top of the line, which is the greater than side. So because the shading is on the greater than side, you want the one with the greater than symbol, which means B is the automatic answer. So you don't have to do every little detail of graphing. You can, right? But there are ways through the problem that will take shortcuts that can get you the right answer too. All right, for number 13, which point is a solution to this inequality? And here's where you've got 2 choices really. You can take and graph the system and find out where the shaded region is, or you can take and plug in every single ordered pair and see who works and who doesn't work. For the sake of showing you picture-wise, I'm going to switch over to a coordinate plane and I'm going to graph them, and then we're going to test out the ordered pairs that are there and see which one is in the shaded area. So here's my ordered pair, or here's my coordinate plane, right? And the first equation or inequality was y is less than or equal to 2x plus 2. So here's positive 2, and then the slope is positive 2. So that's up 2, right 1, up 2, right 1. Okay, and because it is got an equal to piece, it's a solid line. Right? So this would be my line coming through here, a little bit more accurate than that. Okay, and the less than or equal to part means I'm shading down here. Right? The second line in this system, right, is y is greater than negative x minus 1. So here's negative 1, and then down 1, right 1 for my slope. It is a dashed line, which means that it does not include all these numbers. So here's this line, and then it is greater than, so it shades up here. Okay, so the answer region to this graph is where the 2 colors have overlapped, right? And for us, that would mean that it's in this boundary area right here, all the way down to the dashed line. Anything in this darkened region over here will work. So now if you take your ordered pairs and look at them, okay, actually I have just graphed number 14. So let's go back and look at number 14. Right, I just answered number 14 for you in the picture. Right, I've graphed the 2 inequalities on the coordinate plane. You can see that it's on the right-hand side, which would be over here in region 2. So I've just shown you how to get that one graphed. So the answer to number 14 is letter B. All right, let's go back to number 13 and let me do this correctly and show you what the graph of that one would look like. So again, I'm going to show you through graphing, but this is number 13 that I'm going to do for real this time and not number 14. All right, the first equation is 2x plus 2. So again, I think my first equation might have been okay. And it's a solid line. And we shade less than or equal to. So that part I think I had right in the first place. Right, but then when we go to do the second line, here's where mine went different. All right, we want to start at negative 1, and the slope is negative 3. So down 3, right 1, down 3, right 1, or up 3 and left 1 will work. Still dashed. And this time we're shading less than, so that would be this side. Okay, so now the overlapping region is not quite as large. Right, and it will actually give you the ordered pairs a little easier. So here is your shaded region where only the answer can be. If it's not in that shaded region, then we can't pick it. So now if you look at number 13 and the ordered pairs, 0, 0, the origin is not in that shaded area, so that is not the answer. If we go to negative 2, negative 3, that would be left 2 and down 3. That one is in the shaded area, so that one works. Check out the other 2 as well. Positive 1, positive 2 is not in the shaded area. -2, +3 is not in the shaded area of both questions. So the only answer that works for both is letter B. And again, if you had done the plugging in method, you would have also found that letter B worked for both inequalities, not just one and not the other. All right, so moving on to number 15. You are to describe and explain how to correct the error because there is a problem in this picture. All right, the first thing we have to do is put it in intercept form. So that means add x to both sides. 2y is greater or equal to x plus 2. Divide by 2 to everybody. Y is greater or equal to 1/2 x plus 1. All right, so if we look at the graph, +1 should be where our y-intercept is. They didn't do that. They stuck it at +2. Okay, so that's one mistake. And then we need to do up 1, right 2, up 1, right 2. Okay, so here's our line, and it should be solid. Okay, but then we have to check out their shading. It's greater than or equal to, so the shading should be on the upward side of the line, not the lower side of the line. So they have two mistakes in this problem. They used the wrong y-intercept first and shaded on the wrong side of the line. Which are common mistakes that you will find yourself making and having to watch out for as well. All right, for number 16, can you use 0, 0 as a test point when graphing 2x is greater than -5y? And then explain why you say yes or no. Technically, you can use any order pair as a test point. So the answer to this would be yes, right? But would it give you the situation where you need to graph? When you plug it in, 0, 0 is going to give you 0 is greater than 0, right? Which means that side of the line will not be shaded. Right, so you can use any ordered pair according to the question, and it's asking that. What it means, though, if you stick it in and it doesn't work, is that you don't get to shade on that side. Right, we use common sense more than we use the test point, but you have that as an option. All right, for number 17, does the system have any solutions? Right, and then explain. Right, well, you can do this one of two ways. Again, you can try to do elimination, although elimination is not necessarily as good for inequalities, or you can put it in a mode where you can go to graph it. If I get this in graphing mode, then I'm going to have to put it in slope-intercept form. So that's -y is greater than -x plus 5, divide by -1 to everybody, and I get y is less than, because I have to flip my sign, x minus 5. Right? If I take the other one and subtract x, I'm going to have -y is less than -x plus 1, divide everybody by -1. That gives me y is greater than x minus 1. If you look just at the slopes for both of these problems, right, they both have a slope of 1, which means they're going to be parallel lines. And then if you look at the symbols, less than and greater than, they're going to be shaded in opposite directions. So if these are my two parallel lines, one's going to be shaded this way, and one's going to be shaded this way. Right? So does it have any solutions? The answer is no, because there are no shaded overlapping areas. Right? So no overlapping areas. Remember, in a system of inequalities, you have to have overlapping regions or there is no answer. All right, and then for the last part of this video, right, and then I'll continue with another part, the 18, 19, and 20 are matching up your types of systems with the number of solutions and the graphs that they are. So if you have intersecting lines, then that means you are going to have one solution, which is letter C. And because it has one solution, it touches in one spot, right? And it's two separate lines of each other. So it's consistent and independent, because those two lines are independent of each other and then they happen to cross at one point. For parallel lines, that means these lines never cross, so there's no solution. That would be letter B. Okay? And because they never touch, that would be inconsistent, and that's all they can be. Right? And then number 20, the same line, which happens to be the overlapping line, okay, is going to be infinite solutions, which is letter A. And because it's infinite solutions, it touches everywhere and one line depends on the other, so that means it's letter X on the other side. You do need to know these words and these definitions because they will show up in a fill-in-the-blank portion of the test. Okay, this concludes part 1.